What's going on, Alex Bros? It's Mr. C here, and in this video what I'm going to do is show you how to set up the volume function based on what I like to call the box problem. It says here that an open box with a rectangular base is to be made from a piece of sheet metal 14 inches long and 10 inches wide by cutting out a square from each corner and turning up the sides. So first and foremost, this is how us mathematicians turn up. Just kidding about that. So we're going to do part A in this video, and I'll have some follow-up videos for the rest of the parts. It says here, express the volume V of the box as a function of the length x of the side of the square cut from each corner. So here's what's going on here. We have a 14 by 10 rectangle, in which case we have to remove the four corners in order to form the sides of a box. So I'd like to go ahead and mark the dimensions of the original piece of sheet metal. So this will be what I call 14 inches. And then I'll mark the width as 10 inches. And what's going on is we're removing squares from each of these four corners, which gives us four sides, or four flaps, which would be turned up to form the sides of the box. And each of these squares is an x by x, the square rectangles. I'm sorry, the square corners. Ugh. So this square right here is an x by x. This one's also an x by x. So is this one. So is this one. Now, here's something that is important to note about what happens as soon as these four corners are removed. The important thing is that the length changes, and so does the width. So let's maybe focus on the length for a second. All right, we start out with 14 inches, and we're removing x from the left-hand side and also the right-hand side of this side of the entire rectangle. So when that happens, it helps us to see that the length of the base of the actual box itself is no longer 14, but rather it's going to be 14 less these two x's that we removed. All right, so again, we remove x from one side and the other side, so in total we removed 2x from what was originally 14. Now, the width of the box is figured out in a similar way. So if we start with 10 inches and we remove x from one side and the other side, we remove a total of 2 x's, in which case the width of the actual box itself is going to be 10 less those 2 x's. So over to the right, I'm going to go ahead and draw out a box as best as I can. Very janky looking box, but it'll do. And remember, the volume of a box is length times width times height. Well, we have two of those expressions, and we'll figure out what the height expression is afterwards, after I mark these dimensions. So the new length of the box, as we saw, is 14 minus 2x. The new width for this box is going to be 10 minus 2x. As for the height, what you need to note is that x, or the x by x square, help to form these four sides of the box. And I'm going to do my best to try to kind of illustrate the role of x as it pertains to the height of the box. So let's say that I have three sides that are still kind of flattened, and then I'm going to try to illustrate one of the sides turned up. Okay, so here comes the side that's turned up. Recall that the size of the square that's removed from each corner is an x by x. So let's say we looked at this square that was removed. That was an x by x. So if you take one of these flaps and fold it up, the height of that flap, which is also the height of the entire box, is going to be, what do you think? Well, if you look right here, okay, that's kind of congruent to this piece. That would have a length of x. So long story short, the size of the square that you're removing from each corner, or at least one dimension of it, dictates the height of the box. So with that said, we have all three expressions for the dimensions of the box. And the reason why that we needed three expressions here is because in part A we want to express the volume V of the box as a function of the length x. So you may remember from those wonderful days in geometry that the volume of a box is length times width times height. Well, that's not really a function of x. In order for it to be a function of x, the only variable involved on the right-hand side should be x itself. But luckily, we have some expressions for each of these three variables, L, W, and H, that do involve x. 14 minus 2x is the length, 10 minus 2x is the width, and then x is the height. So all we have to do is just substitute those expressions in, and I'll use parentheses. So 14 minus 2x, 10 minus 2x, and then x. And I'm going to rewrite that so that x is in front. So we have x times 14 minus 2x times 10 minus 2x. And I would leave it in this factored form. It's a little easier to type in the graphing calculator. And notice that the only variable being used in this expression is x, meaning that we can rewrite v using function notation, v of x. Okay, that does not mean v times x. This means v of x. From a practical standpoint, it says this is the volume as a function of x. So when you pick different values of x, you can plug them in, and this formula gives you the corresponding volume. All right, there are some conditions on x that we do have to be aware of, but that'll be saved for the next video. All right, so this is all we need to do for part A. Of course, if you have any questions whatsoever about what was presented in this video, feel free to let me know. Otherwise, thanks for watching, and I'll see you in the next one.